Number 5, we've got this integral to evaluate. And so if we start thinking of things that we can do, the only algebra you could try to do is multiply it out, but that makes it worse. You get x plus the square root of x. That doesn't really help me, having 1 over that. You can't just say take negative exponents of this, because that's you have to have it all to 1 power to get rid of these things from the denominator. Can't split it up, can't factor other than to get back to here. So algebra is just not going to do anything for me. It's not an integration by parts or a trig integral, so I'm going to have to use a substitution. And so what I'm looking at, I see this parentheses, it's kind of drawing my eyes to that. It's not really an inside function, but it's sort of substituting for the denominator, even though there's something else in the denominator. Because when I substitute for this, do you see that I get 1 over 2 square root of x dx? So sort of thinking of this as being 1 over square root of x plus 1. Substituting for that denominator, this 1 over square root of x is going to still be there, meaning I can replace that by 2 du. So it's kind of camouflaged a little with it stuck in the denominator with it, but even if you leave it there, this will still happen. You can still get that to replace, and so doing that, I get a u in the denominator, and then 2 du is going to replace, oops, there's a dx here too. 2 du is going to replace the rest of that, so 2 du. And now this is just going to be 2 natural log absolute value of u, just pulling the 2 out of the integral if you need to, it'll come out, which is going to give me 2 natural log square root x plus 1 plus a constant. And it turns out you don't have to have the absolute value on this particular one because square root of x plus 1 is positive, but that would be your integral. Okay, let's look at number 6. Alright, so again, we've got to kind of think of our different steps of what we might try to do. You see this is an inside function, but if you try to substitute in for this, your derivative is going to end up having a sign in it, and there's no sign integrating factor that's going to help. So substituting for that inside function is not going to be the appropriate way to approach this one. And so it's not integration by parts because it's kind of messy if you even try it. It's not a trig integral because I don't have trig functions to a power. So I'm going to try to use algebra or trig. In this case, I'm going to try to use a trig identity. Hopefully this sort of jumps out at you. Remember that sine squared x can be rewritten as 1/2 1 minus cosine 2x. And there's nothing special about x. If this were 2x to begin with, then this one will be 4x. So sine squared 2x is 1/2 1 minus cosine twice the 2x. And so if you read it this way, that's exactly what I have there. This is the integral of the square root sine squared 2x. And we'll just drop the square root and the squared, so this is really just the integral of sine 2x, which is 1/2 cosine 2x plus a constant, and that should be negative.